Thank you, everyone, for being here. We are so excited to have you at the ATARC Quantum Speaker Series webinar. As always, we're so excited to present some really interesting, innovative work that's happening in the quantum space. We are hoping to get to Q&A, so please put them in the Q&A button at the bottom of your screen, and we'll try and get to them at the end. First, I'd like to thank Dana Linnett from Artificial Brain for joining us today. She's a senior executive and marketing engagement at Artificial Brain USA. Dana is a former senior U.S. government official and a diplomat. After leaving the government, she has served as defense and aerospace executive at Lockheed Martin. She has also served as sales director and senior advisor at Guidehouse LLP's national security sector and global VP at a Silicon Valley AI startup. She is also the CEO of the Summit Group VC, a consulting group that specializes in space, net zero, defense, and emerging technologies. And with that, Dana, I'll turn it over to you. We're so excited to hear from you.
Thank you so much, Allison and Elizabeth, for the intro. Good afternoon, everyone, and thank you to ATARC for the opportunity to speak with you today. I'm very excited about this. As Allison said, I wear many hats, but today I'm focusing in on Artificial Brain's quantum technology and our collaborations that have borne out that our research in quantum technology. After introducing the company and our technology briefly, I'm going to then present our space and energy research, including our benchmark results, which I'm sure is of interest to some of you. Although it will be more focused on the space side for this presentation than energy, but we will touch on both. And as we have varying degrees of expertise, including many people tuning in today who are newer to quantum, or what I call quantum curious, I will do my best to de-geek the presentation and make sure that the information is accessible to both scientists and non-scientists alike. So with that, let's do this. We'll go to the next slide. And I'll introduce our company. It is, as the slide says, we are a quantum annealing software company based in the US with companies in the Netherlands and India. And we are looking to change the world and change the universe. We are tech heavy and international as far as our team composition. And we are creating our technology in our trusted tech network that can be used to advance free nations for the good of humankind. As you can see, collaboration is important, but we also make a point of doing this as safely as possible. Next slide. So with binary code, as many of you know, and our AI algorithms, we know that there are time and compute constraints and limitations that make solving super complex problems with a highly dynamic environment really challenging. So at Artificial Brain, we have developed quantum algorithms and have had some pretty good results with our quantum computing, and I will get to that in a little bit. But we are being able to take on that level of complexity and challenge, and we're able to do it faster and more accurately. Okay, next slide. Right, so quantum annealing versus other types of quantum. I know I'm just going to put the elephant in the room out in the room and just say, start with some basics as well. So basics is that, the quantum industry in sort of very simplistic terms can be looked at in terms of hardware and sensors, cryptography and communications, and software quantum algorithms, and the latter is where we play. There has been, the elephant in the room is that there's considerable work going on in all of the areas, but there's been this weird division cropping up that we've noticed at conferences and things between the quantum gate community versus quantum annealing community. We at Artificial Brain have been running our optimization software on quantum annealing because we have found that that has been ideal, but we are open to continuing our exploration and our collaborative research on various types of hardware. But for the sake of this specific talk, just to put it out there, we have run all of our software R&D experiments that are discussed here on D-Wave's quantum annealing hardware, and we've achieved some really good results, and that's the data that I'm going to present today. Just on this, for those that are interested more in like the space applications, there's a fun article that I've put the hyperlink here too that we can send out later, but that talks about, like, I don't know, dozens of potential use cases for quantum and solving the most challenging problems for space specifically. Okay, next slide, please. We had some great wins earlier this year or throughout the year. Back in May, we won the European Union, USPA space program competition in the prototype and in the prototype track. And we did it with the Earth observation satellite experiment that I'm going to show you today. So just had to put in a little plug of some good news. We've won some other competitions, and we have a lot of work going out in numerous countries and domains. Right, so Earth observation satellites. As you can see here, this fun video with the satellite traversing the Earth and the optical equipment bearing down on particular areas and targets. So again, this is just to give a little imagery of what we're going to be looking at. Okay, next slide. Sorry, next slide. There it goes. Next one over. There we go. All right. So I always like to say the so what, as a diplomat, we used to think lofty thoughts, and the secretary would always say, but so what? Like, why do we care? Well, we care specifically about Earth observation satellite from multiple perspectives. On this slide, we're depicting some of the applications that are actively being utilized today, fire monitoring and resource deployment. I mean, who remembers the volcanoes? The volcano crisis of the ash, about a decade ago coming out of Iceland, and now we have more ash, Canadian fires, California fires. Where do you deploy your firefighting resources, or how do you divert air traffic, or how do you deploy any other emergency management resources? So, that's one use case. Water pollution is another. There are a lot of illegal dumpers and other things happening. And so how do you have that level of surveillance from space that can give you that monitoring? Same with crop monitoring and farm utilization. So how do we optimize the challenges, especially with climate change on that? I will note a couple of other Earth observation satellite applications. One is in particular in the national security space. So if you've read all the open source, news articles about Space Force and NATO, we have, satellite assets that are coming up in the thousands just in terms of the government space. And then when you apply that to, almost 30 NATO allies with space assets, and then also if you've read Space Force's doctrine about pulling on commercial satellite Earth observation capabilities, and we saw that with particularly like Maxar and Planet and other companies during the Ukraine war. So, if you're pulling on like thousands of different satellite, types of optical resolutions, targeting capability, and you have competing targeting interests among multiple offices and multiple agencies, there is a level of complexity there that the current computational technology is not able to solve. And yet we believe that quantum optimization provides the answers. And those are the kinds of optimization problems that we're working on. Next slide, please. Other way. There you go. Okay, so this is a very rudimentary, because a lot of our work is proprietary, but this is our sort of open source, Earth observation satellite optimization experiment that we ran. So if you look there on the left side, you're looking at a number of targeting priorities, but you also have a number of constraints. So satellite imagery is dependent on many things, from weather and interference to ground link station, downlink times, uplink times, storage and energy limits, cloud cover. I mean, depending on the technology, there could be infinite number of constraints that are going to interfere with or degrade, or in some cases, if you have the right conditions, it can optimize your Earth observation capabilities. But in any case, when you start applying multiple constraints across multiple constellations, and you'll see here the lower right side, we show we're just depicting 3 satellites, but you could have 1,000 satellites, 100 satellites, whatever your constellation is. And it might not even be your own constellation. It might just be satellite assets that you either as a company or as a government might have access to. So we show the multiple constraints across multiple space assets. And that's the kind of NP problem that we are trying to solve. So if you continue to go next way, okay, so here's another kind of visualization. So you have a satellite flying over and there are tons of targets. Let's say you're doing some wildlife monitoring and you want to follow where the elephants are going or any other kind of, issue that you're looking at. How do you know what to look at from which asset at what time with the limitations and the constraints that you have? And how do you know which images are the highest value, either highest value commercially or, highest value in terms of prioritization of the kinds of problems a government or a civilian space agency might be trying to solve or answer? And so this is an example of, on the left, we see lots of dots showing lots of targets. On the right, we show that our algorithm is picking out exactly the right targets at exactly the right time across the right assets and so on. So that's just a rudimentary depiction. Next slide, please. So what are the results? So we did our benchmark results using Gurubi Optimizer, which was one of the best known AI optimizers in the world. And we said, how does artificial brain's quantum algorithm run on D-Wave's quantum hardware? What are we getting in terms of like for like data going in and speed and accuracy levels in order to solve for all the constraints and to solve all the questions that we had? So with the classical versus AI, we ran 100 rows with 1,000 targets. That's there on the screen. And we outperformed Gurubi by almost 40% in speed and at almost 25% in accuracy. At some point, when we started to add on a high number of constraints, Gurubi went into infinite loop and completely failed. Now, we talked to companies that have not been as successful with their quantum versus Gurubi experiments. So if you're one of them, we would love to talk with you and work with me and Allison, and we'll see what we can do to try to run a like for like experiment and figure out what, what that discovery might look like. But for what we're running in terms of our proprietary algorithms, we are finding that we are having quite good results. And, across a multitude of experiments, whether we're doing them on energy, like constraints such as EV charger layouts or wind farm layouts, or, if you have a highly dynamic energy sector where you're crossing state lines with lots of sources of energy generation at different peak times, and you have different customers pulling on that energy source at different times, we're able to optimize those kinds of problems as well. We have found that we've been quite successful, and we would love, again, to work with others who maybe have not been as successful. Okay, next slide. Okay, a little plug for D-Wave, here, but this use case is one of the featured applications on their website. So you can look at it on our artificialbrain.us website, or you can go to D-Wave's website and look at our Earth observation mission planning using our quantum algorithm. Okay, next. I wanted to highlight some of the other space applications and white papers that our research has led us to. So on the left-hand side there, you see quantum for Mars exploration, opportunities and challenges. This is really important because, NASA is looking at, and as are other countries, how do we get to Mars? The time travel is, time to distance is one issue that we're not as interested in, but it's the once we get there. So how can we make human civilization possible in a Mars or Martian environment, from things like finding new materials and energy sources to optimizing fuel, and doing that in a way that is uniquely Martian, right? So we're looking at our quantum optimizations and our quantum computing to do that kind of mission planning. Again, very complex and doing it very fast and accurately as we know how. Another major problem is space debris and situational space awareness. So whether it's NASA or commercial companies or national security space assets, the space debris problem, the Kessler syndrome, how we deal with just the ever expanding amount of space debris, especially in lower Earth orbit, or LEO as we like to call it. It presents a number of challenges from, how do you reduce the creation of your asset becoming space debris in the first place? So, I guess, sort of a preemptive way of, or a preventative way of becoming space debris, to how do you keep assets safe from collision? How do you mitigate the risk of collision? But also, how can we clean up the space debris? There are a number of companies that are looking to kind of scoop everything up and recycle it in space. So how can our algorithms get at this really critical issue? We've recently submitted an application to the Canadian government on this topic, and we would welcome, obviously, US and other collaborations on the issue. And then, space sustainability is also a major issue that we're looking at. I won't get into the satellite placement. That's another one that is an entirely interesting thing. It's not just that you launch it and you figure out what to target, but it's like, where in LEO do you place it? When you start combining that with the space debris problem, it gets kind of interesting. So these are just some of our research papers, not all of them, but it gives you an idea of the kind of hugely challenging problems that we're trying to solve, that we believe we can start to solve right now using the technology as it's currently available, which will only improve over time. Next slide, please. There we go. There we go, Mars optimization. This is just, again, how do we deal with simulation for mission planning, secure communication? Artificial brain is working on quantum machine learning. One of our advisors, Bill Gonzalez, he's the CEO of Webhead. He's a long time, he's been doing a lot of work on quantum and quantum machine learning and machine learning in general. We think that when we combine, just like we do with our current algorithms, when you're combining the actual computation with the machine learning piece, we can accelerate these transformational advantages like even more quickly. So we're working on that as well. Next slide, please. This is a use case for space sustainability that was conducted in the UK. It's not ours, but it's just to say here that when we look at current available AI versus quantum computing, we can see here, just if you just go to compute time alone, you're looking at a massive difference in just the time it takes for quantum versus AI to compute. And actually, we found that as well. Like, we did computations that took Gurubi 4 hours or more to solve, but it took our algorithm about 0.035 seconds. So almost, identical to this sort of result. So that's the kind of, I know it's hard to imagine it, but that is the kind of game-changing result that we know quantum is delivering right now for us and for others. Next case, please. Again, on energy, we just received a grant from the Netherlands UK network to do a white paper on wind farm optimization. This is a paper that we developed, I think it was last year, that we presented to a couple other energy companies that are looking at their own wind farm layout, plans, and how they want to put their capital into developing those wind farms. So this is really important for net zero and also the transition. I mean, we're going to be relying on a multitude of different types of energy sources. And, our government might not be able to keep up with some, aspirations. And at the same time, we do have some reliance on other energy sources, whether it's nuclear or carbon-based. But in terms of decarbonization, or in terms of getting our energy to work for us as citizens without spiking prices and without wasting capital expenditure, operational expenditure. That transformation is super complex, and it's super ripe for what artificial brain is doing with our partners on these types of issues. So again, we've thrown a lot of research at this, and it's been accepted in multiple countries and with multiple types of customers. And again, it's not just for governments. Companies right now can be reducing the amount of money that they're spending on a lot of their operations and be able to, increase their profit and revenues and margins at the same time. So there is a really solid business case for this, along with a solid humanitarian case, if you will. We wouldn't be doing it if it wasn't a business case. So I tried to keep it to the 20 or something minutes or so. I know that we have a lot of people on the line with a lot of questions. So I'm happy to take your questions, and any questions that we can't get to in this session, there are our emails. Please feel free to email us, and we can give a more substantive answer in due course. So with that, I thank you very much.
Thanks so much, Dana. That was fascinating. We do have a question in the Q&A. Has artificial brain done any non-classified work in reconnaissance space?
I think you can say yes if you're looking at I think you can say yes if you're looking at Earth observation satellite targeting, because targeting in some senses is reconnaissance, and we have been looking internally at how that would look for let's say a space warfighting perspective. So if there are people out there who want to work with us on that in a non-classified way, we can vet that and have a discussion. But
great, thank you.
I hope that answers the question.
It does. Chris Robinson, you have your hand up. Do you want to come off mute?
Chris?
Disregard that. That was an error.
Sorry.
Okay.
So I have a question for you, Dana, as we wait for folks. You can put it in the chat or you can put it in the Q&A. Given the work that artificial brain has done in Europe and the Netherlands, and you mentioned Canada, how are you seeing the engagement with quantum applications here in the United States?
Yeah, it's been really interesting, and I think we're still trying to process what we've been experiencing. I think in Europe, you have a lot of small countries that recognize that they need foreign direct investment and talent, and they're just smaller, so they're more reliant on the outside world to come to them to collaborate. And I do want to talk about collaboration, because part of this theme is collaboration, right? And I do see them, especially the Netherlands, they have bent over backwards for us, as has Canada, frankly. They have been very forward-leaning. It's existential, I think, for many of our advanced NATO allies in Canada, from both a commercial and a national security perspective. And so I feel like we've been super warmly welcomed there, and I had a lot of success engaging with even some of the accelerators and investor communities in those places. There's always a chicken and the egg, like set up an office here and then we'll give you money. And we're like, well, if you give us money, we can have money to set up the office. Like, we can't be everywhere for a completely bootstrapped company that we've got, a global presence in 3 countries and are doing research in 5 others. I think we're doing pretty well. But that's been an interesting thing. I think in the US, it's been a little more challenging. I think the way that export controls and things are looked at in our country around quantum, and I'm hoping that loosens up a little in a safe way. I think it can be done. But it's just weird. It's like, we're trying to sense how much the VC market really knows and understands about quantum, and who are the real experts that they're talking to and engaging. In the US government, there's a definitive strategy, and that strategy is very clear. I feel like it's very good, but it's also focusing limited resources on limited capabilities that tend to exclude the very things that can accelerate the transformation in those areas. To me, it's like counterintuitive, like, okay, you only want to do this type of quantum research, but we have this type of quantum research that can help you accelerate the kind you want to do. They seem to be limited in their imagination, in my personal view. I won't speak on behalf of all of artificial brain, but I do feel like there's some, we've run up against some real limited and limiting beliefs. And if you're a scientist or, you're an entrepreneur, like those are the kinds of things you just obliterate. I've been in government, I've been a bureaucrat, I speak complicated bureaucraties, and it's the kind of stuff I always try to obliterate with my bureaucratic sledgehammer. When I was in government, I tried to do, break through that, but we do find it at an odd time. Like, I think now is a time where a lot of investors want to get into quantum, and this, I would say, if you're on the fence about quantum, now is the time to get in. And I'm not just saying that because of my artificial brain hat. I'm doing that with all my hats on. This is an excellent time to invest and get in. This is only going in one direction, and you're either on this train or you're not. And it's always going to be going forward. So this is for a long-term or even medium-term proposition. This is a no-lose proposition. But I do find that it is a little weird to navigate the space here. And I'm not sure if I'm answering your question.
No, you did answer the question. No, that was perfect. And actually touching upon the collaboration that you had mentioned, there's a question in the Q&A about compared to the accelerated work that's happening in US and Europe, what sort of collaboration is happening with India, whether it's with United States and India or India and other countries?
Right. So I'll talk about our collaboration in general, and then I'll put it in the India and other contexts. So at Artificial Brain, we realized that, quantum R&D, or building our product or productizing our algorithms, that is, and staying and advancing things, we have to advance and advance and advance. That depends on the academic community, and that, and that R&D, it depends on international collaboration, because no one country has the sole exclusive omnitalented workforce in quantum. It's a very small, human resources pool. So collaboration is essential. Cross-border collaboration is essential. Academic research is essential. And then working with our customers on actual problems is essential, right? I think so it takes all of these dynamic types of collaboration to then, to build and improve and advance, so that, those gains can be pushed into the market space, which is where it really needs to be, right? And then as far as the government side in India, it's very interesting. So when Biden and Modi had their summit, and I followed this really closely from the inside and out, they focused the quantum collaboration in two distinct areas. One was like the commercial side. And so Artificial Brain has submitted both from India and the US, because we can do that, because we're global. So we have submitted some of those commercial applications for that commercial unclassified type. Well, it's all unclassified, but that type of collaboration. Meanwhile, a friend of mine has been charged with helping to stand up InduceX and the whole sort of India-US X, meaning, this experimental collaboration, kind of like FedTech and X-Tech. This is InduceX. So there is this defense-related pillar. So there's a commercial pillar and scientific pillar, and then there's this more government-ish type space pillar. And so we've applied to everything because, especially with Jitesh Lawani, our CEO is, he's from Pune, India. And we're working in this space, but it is not easy, because I think too, in India, they're trying to stand up the right infrastructure and the right business groups. And there are some challenges that we've already encountered with that. And we're trying to be helpful and inform everybody with what we're seeing. And especially if there's something that needs constructive addressing, we try to do it behind the scenes, because we want everyone to be successful in the space.
Mhm.
If everyone is cooperative in the quantum space and helping each other, even kind of on a competitive basis, I think at this early stage, especially, it's only going to help propel the whole industry. I think we really all need to do a little bit more, talking amongst ourselves and then pushing that story out to the general public. Right now, the general public has no idea that their lives are about to go upside down. And I mean, beyond quantum cryptography and the ability to ruin the entire financial system, like in a second, or, colliding all space assets in a second, or whatever you can do with quantum clocks and precision. But I mean, just the everyday banal problems that we're going to be able to solve, especially with optimization and annealing, with annealing technology, that's something that could be really accessible to everyone on so many levels, on just everyday, like, convenience and people levels.
Well, thank you so much. I know we're at time, and I want to thank everybody for attending. If you have follow-up questions, Dana and Titesh are available. Their emails were provided on the slide deck. If you'd like to reach out to ATARC, and we're happy to connect you. Thank you again, Dana.
And
Please.
Jeanette Chu, I see your question. I owe you a lunch. And I'm happy to talk about Senator Casey's proposal on private equity and so on. But yes, I think that's a longer lunch between us girls, Jeanette, and I can't wait to schedule that with you.
Yeah, I figured it was too long of an answer for the 30 seconds we have. So thanks everybody for coming. Thank you, Dana, for being with us. We really appreciate it.
It's my sincere pleasure. Thank you all. Have a great
Bye-bye.
day. Bye.